Alright kids, welcome to your video on the polynomials basics, including addition and subtraction. Tonight I'm going to play Michael Jackson in the background. And this is from your textbook, Chapter 8, Section 1. Alright, let's jump right in with definitions. Okay, a monomial is a real number, a variable, or a product of real numbers and or variables. So, examples of what's a monomial: a 3, that's a monomial; an x, a 3x; 3x squared, 3xy. As long as it's a number, a variable, or a product of numbers and variables. Just no addition and subtraction. Notice that in that definition. The degree of a monomial is the sum of its exponents on the variables. The degree of a non-zero constant is 0, and 0 has no degree at all. And we'll do some examples in coming slides. A polynomial is a monomial or a sum of monomials. So poly, many, and hopefully now you get the joke that was on the original slide. You might want to go back and look at it if you didn't pay attention. The terms of a polynomial are separated by addition or subtraction. Okay, so polynomial, poly, many, mono, one. One term, many terms. Let's look at finding the degree of a monomial first. So here's a couple of examples. What's the degree of 5x? Well, the exponent there in 5x has a 1 on it. Therefore, the degree is 1, and you can see that here. On this next example, we have 6x cubed y squared. We're going to add the 3 and the 2 because those are the exponents, and the degree is 5. You're not going to see a lot of expressions like that. Really, finding the degree of that is pretty much the only thing we do at this point. 4. Well, 4 is a non-zero constant. A non-zero constant has a degree of 0 because it's like saying 4x to the 0 power. So, let's find the degree of each of these. So take a second and go ahead and find them. Alright, you should have 2 for that one, 1 plus 1, because that's the degree on each variable. You should have a 5 for this one. The negative does absolutely nothing to the degree at all. So 4 plus the z. Notice the z is just a z. That's z to the first power. So remember, that's 4 plus 1. Just like over here at a, it was 1 plus 1. And x, that we could say 11x to the 0. So that is a non-zero constant, has a degree of 0. When we classify polynomials, you're going to do it by degree. And there are the names by degree, we'll go over in a second, and then number of terms. So, a degree of 0, that's constant. When you have one term, that's a monomial. So 6 is a constant monomial. Degree of 1 here for 5x plus 9, that's linear. Degree of 1 is linear. Because if I was to put y equals here, it would make a line. That's why we call that linear. This particular expression has 2 terms, making it a binomial. Next one, 4x squared plus 7x plus 3. Quadratic is the degree because that's what we call a degree of 2. If we set this equal to y, we would get a quadratic shaped graph. And I think what's important to think here for quadratic is it's squared, it's x squared, and I think that's where the quadratic comes from because a square is a quadrilateral maybe. Next one, you have third degree. Third degree is cubic. So going back to number of terms, 3 terms here, trinomial. So that was a cubic trinomial. And then this, quadratic trinomial. And this one's a cubic, and it's 1 term, so it's a monomial. Fourth degree, now at that point you just have the names by number. 4th, 5th, 6th, 7th, 8th. Okay. Coming back just for a second to the trinomial, to the cubic part. A 3-dimensional shape that's all squares on each side. Not my best cube work there, but it'll do. Oh, that's just terrible. Never mind. Anyway, a cube has 3 dimensions. Okay, standard form. When you write a polynomial in standard form, you write it in decreasing order of degree. So 4, 2, 1, and then 0 in this example. And again, we name it for the degree and number of terms. So we're going to write these in standard form, or the examples are done where you've written it in standard form and then named it. Okay, so let's look at the first one. We've got 3x plus 4x squared. When you rewrite it, we're going to write it 4x squared plus 3x first, and that is 2 terms, so binomial. The degree of 2, so it's quadratic. Okay, on this next one we have 4x minus 1 plus 5x to the third plus 7x. We're going to place it in order, and then we've got like terms to combine right here, making 11x right there. 3 terms, trinomial, degree is 3, cubic. Okay, so the degree of a polynomial is the highest of any of the degrees of its terms. So this is a 4th degree polynomial because the highest degree in there is a 4. So it's not like a monomial where you add the separate exponents, it's the highest one. So let's name this one. So let's write it in standard form first. So decreasing degree, 8x squared plus 2x minus 3. So that's 3 terms. That's in descending degree. So that's standard form. 3 terms. So it's a trinomial. And then what's the degree? Highest degree of any one term is a 2. So it's quadratic. Quadratic trinomial. All right. Now we're going to look at adding and subtracting polynomials. So in order to add these 2 polynomials here, we're going to add the like terms, and then we're going to write the sum in standard form. So let's start with adding the like terms, and I'm going to color code it. So I've got x cubed, and there's an x cubed there. So right there, we're going to add those together. 1x cubed and 7x cubed is 8x cubed. Minus 3x squared plus 5x squared. Minus 3 plus 5, think about it for a minute. Minus 3 plus 5, that's a 2. So positive 2x squared. Switch colors. Plus 5x plus, nothing there. So we just have plus 5x. And finally, we have minus 12. Sorry, I'm trying to get my colors in order here. Minus 12, so we have on there minus 12. 4 terms, so that's it's just 4 terms, so it's a polynomial. There's no name for that. We have mono, bi, and tri, but no 4-term name, and it's cubic. Okay, and we're done with that problem. So we added the like terms, wrote it in standard form. Subtraction. Subtraction is a little bit tougher because you have to think about a whole bunch of sign switching. So let's start with we've got to change the subtraction to addition and switch the sign of each term that's being subtracted. Okay, so we're going to, and then we're going to add and write it in standard form. So let's start. I'll start with the purple this time. Or actually, no, hold on. Let me think about this for a second. All right, so I'm going to use kind of a different color. I'm going to use kind of an orange here. And what we're doing is we're saying we're going to switch the sign to addition and switch the sign of everything that comes in the second parentheses. Because that is the definition of subtraction, adding the opposite. We've been joking in class that we're not supposed to subtract anymore. What we're really doing is adding the opposite. So now I can go through and just add the like terms together. So this time I'll instead of color coding, I'll do it like this. We got x cubed and negative 7x cubed. So that's negative 6x cubed. Minus 3x squared and negative 5x squared. That's minus 8x squared. Negative 3 and minus 5, or not minus 3 and minus 5. Plus 5x is the same as the previous problem, but now we have a plus positive 12 instead of a minus 12. Now we can look at that horizontally like we did here, or we can look at it vertically like this one over here. And what you can do is, again, you can use the adding the opposite of each term. And now I can just add straight down. So I can x cubed and minus 7x cubed is negative 6x cubed. Minus 3x squared minus 5x squared. Oh, that's supposed to be a squared. Oh, I apologize. Yeah, that's right. That's supposed to be a squared. That's just a typo on my part. Sorry, guys. All right, so minus 3x squared minus 5x squared is minus 8x squared. Before you all Edmodo message me, notice that I fixed it. Anyway, plus 5x plus 12. So this is Beat It that's playing in the background. I really hope you can hear the music. When I was a kid, MTV was all videos and not awful reality television. And this was the funniest video, in my opinion. At some point, you should look it up. It's entertaining. Ask your parents first before you do any random Googling. Okay, Why don't you try a couple of these? Okay, I'm going to let the music play for just a minute. You go ahead and pause it, simplify them, answer the questions, and then I'll go back and do it too. All right, here we go. Find the degree of each monomial. So the first one only has an x to the fourth, so it has a degree of 4. Nothing else to do there. Add the exponents in the second one. 2 plus 3, degree of 5 on the 8y squared z cubed. Adding the like terms up here in the next example, we got 5r cubed and 6r cubed. That's going to be 11r cubed. And we got plus 8 plus 3. That's going to be plus 11. Okay, whoops, wrong color. Plus 11. There we go. All right, next one. Again, let's use our keep, switch, switch. Let's use our keep the beginning, switch it to addition, switch the sign in both for the both terms in the parentheses. Okay, very hard to do when it's all this small like that. So x squared, no other term to combine with that. Minus 2 combines with a plus 5, or minus 5 because I switched the sign. So that should be negative 7. I'm going to put that on the end. And then I have a plus minus 3x, or plus negative 3x, so minus 3x. Okay, I'll go back and double check that because that felt awkward. I'm not sure that's right. All right, name each polynomial based on its degree and number of terms. We have squared, quadratic. So that's quadratic. So it's a quadratic. And it's got how many terms? I heard someone say it, 3. Quadratic trinomial. What about this one? First degree, linear. How many terms? 2. Binomial. Almost out of space. All right, compare and contrast. How are the processes of adding monomials and adding polynomials alike? How are the processes different? I think that's a really silly question, math book, for you to ask. So I've decided that we don't want to answer that. We know that when we're adding monomials, it's individual terms. When we're adding polynomials, it's more than one term. Hope you enjoyed the video. Hope it didn't end up too long. See you in class.